Hello all, welcome to Math2Go. Today we are looking into a very interesting function, namely x to the power of x, where x is a positive real number, and we are asking ourselves what the limit of this function is if x tends to 0. So this is really interesting because if x tends to 0, we have some term of the form 0 to the power of 0, and it's really interesting to see what the limit is here actually. So let's do the first observation, namely f of x equals x to the power of x is the same as e to the power of x times logarithm of x. This is due to the fact that a to the power of b always equals e to the power of b times ln a. And we plugged in x for a and b. The second observation is for continuous function, and the e function is a continuous function, so e to the power of x is a continuous function, we can always switch limit generation, limit calculation, and function operation. So it holds limit of x, where x tends to 0, of f of x is the same as e to the power of limit x goes to 0 of x times ln x. And we can use this to our advantage, because now we just have to look for this limit here, for this one. Yeah, and let's do this in the third step. So the limit where x tends to 0 of x times ln x is, and now we can use a good trick, the rule of L'Hopital, and we already did this in the past video. I will link it down below. We have something of the form 0 times minus infinity, because ln x goes to minus infinity when x tends to 0. So we have something of this form here. And then if we have something of this form, we can rephrase it, reformulate it before using the rule of L'Hopital in the following way. We can have ln x divided by 1 over x, and this is exactly the same as before, as x times ln x. It's exactly the same. So now we can apply the rule of L'Hopital, because we have some form of minus infinity here and infinity here. So we can take derivatives, and this is not infinity, it is 0. So x tends to 0 again, and then the derivative of ln x is 1 over x, and the derivative of 1 over x is minus 1 over x to the power of 2. And we can simplify this further. Just switch them and multiply with the numerator, and then we have 1 over x times x to the power of 2, and this equals just minus x. Firstly, this equals the limit where x tends to 0 of minus x, and this is exactly 0. So now in the fourth step, we can just plug in our result here into the e function, and this gives us the limit of x, where x goes to 0, of x to the power of x equals e to the power of 0, and this is 1. So 1 is the result. Yeah, 1 is the result, the limit of our function f of x, where f of x equals x to the power of x. So I hope this video was really useful to you. If yes, please leave a comment and subscribe, like the video, and stay tuned for much more in the future. Thank you.